Hi guys! So, you already know just how important the sun is to life on Earth. It makes the plants grow, and of course, we have the sun to thank for solar energy. So, energy from the sun is the result of a process called nuclear fusion. This is a reaction that happens in the sun's core. There, extreme heat and gravity turn hydrogen atoms into helium. The process releases energy which then radiates out in the solar system. For many years, scientists have tried to recreate nuclear fusion on Earth. But why? Because it could provide humans with a clean source of energy. This could help lower carbon emissions and the levels of other greenhouse gases in the atmosphere as well. That possibility has led some scientists to the idea of creating an artificial sun. What do you mean by artificial sun? Are people creating giant ball of gases that can heat planets far from the center of our solar system? Of course not, or at least not yet. Instead, the artificial suns being created today are nuclear fusion reactors. Unlike fission, fusion does not emit greenhouse gases and is considered a safer process with low risk of accidents. Even if it occurs in the sun naturally, creating sustainable fusion is hard. On paper, it's pretty simple. Smash some atoms together and soak up the energy. But in reality, creating the equivalent of an artificial sun is much harder. Firstly, the sun is 1.3 million times larger than the Earth. The kind of gravity the sun's mass yields is impossible on Earth. Secondly, fusion of hydrogen at the sun's core happens in a stellar oven that burns at an intense 15 million degrees Celsius. For scientists on Earth, the challenge isn't only in creating the pressure and heat necessary to fuse hydrogen, but also in keeping it contained. So they use magnetic fields to keep it suspended. That's more challenging than it sounds. Containing turbulent molten plasma at just the right conditions for fusion under high pressure while subject to heat in the millions of degrees Celsius requires significant research, experimentation, and continuous trial and error. Once mastered, nuclear fusion could potentially provide unlimited clean energy and very low cost. China's experimental advanced superconducting tokamak, which is called as EAST and also called as China's artificial sun, has recently set a new record. It ran at 216 million degrees Fahrenheit, that is at 120 million degrees Celsius for a total of 101 seconds. But China is not the only country that has achieved high plasma temperatures. There are many in the race. Many are hopeful about this means for the future of energy. People around the world grow more concerned about the climate change and rising sea levels. They hope nuclear fusion will offer a more sustainable energy source. Have you ever thought, how long can Earth count on heat and energy from the sun? Most scientists say for another 5 billion years or so. At that point, the hydrogen that fuels the star's nuclear fusion will run out. The sun will expand to become a red giant. Will humans have created a replacement for the actual sun by then? Well, we can't predict the future, but today's artificial suns can be an encouraging sign. What do you think of human-made suns? Could they be the future of energy? What other uses for this technology can you think of?